Welcome to all. We'll start the subject control systems. Control systems. So this is one of the scoring subject in GATE exam, like digital networks, signal systems, and control systems. These are the we can get very easily a good score because it's a problematic subjects. So if you have enough practice in the problems in various methods, they'll get very good score. So first we'll see the what is the syllabus. Just overview we'll see. First unit, basics of control systems. Basics of control systems. So in this, what we will study? Basics of control system. So different types of control system components, like classification of control systems, the open loop control system and closed loop control system. Then what is the feedback we are applying in this system, whether it's a negative feedback or positive feedback, and what is the advantage of negative feedback over positive feedback. That and all we'll discuss in this. Then how to find out the transfer function by using a block diagram reduction techniques and signal flow graphs, that is a Mason's gain formula. That and all we'll discuss in this unit. Then next unit is time domain analysis. Time domain analysis. We'll study the response of any system in time domain. We can classify into category like transient response and steady state response. So in both transient and steady state, how to discuss the stability of the system, like a over-damped system, under-damped systems. So depending on the damping ratio, different cases are there in the system. Then we'll see the type, number and order of the systems. Then time domain specifications like raise time, peak time and peak overshoot, okay, and the steady state error and steady error constants. This and all we'll discuss in this unit. Then third unit is concept of stability. Concept of stability and Routh-Hurwitz criteria. Next unit is root locus technique. Locus technique. So these are the there are different types of techniques are there to find out the stability of the system. That is first Routh-Hurwitz criteria. For any characteristic equation of a system, we can find out the stability of the system. If it is unstable, that means there are roots lying on the right half of the S-plane, and we can also find out the number of roots lying on RHS, like right hand side of S-plane, by using RH criteria. Then root locus technique. In this unit we will see how to design the root locus diagram and find out the range of k values for the system stability. This and all we will discuss in detail in root locus technique. Then fifth unit is frequency response analysis. Frequency response analysis. So to test the stability of the system, to test the analysis of the system, there are two ways. One is the time domain analysis and frequency domain analysis. So in frequency domain analysis is more clarity over the stability point of view, in which we'll see what are the frequency domain specifications and different plots to check the stability of the system, like polar plot, border plot, Nyquist plots, okay. Then M and N circles, nickel charts. So these are the different plots to discuss on the stability of the system. The next unit is compensators and controllers. Compensators and controllers. So why we have to use compensators or controllers? So compensators are used. There are two methods to improve the system performance or the response. One is the constant gain k, values changing from 0 to infinity. That is one aspect to improve the system performance, and other aspect is compensators like RC circuits, like passive circuits, like low pass filter or high pass filter. So lead compensator, lag compensators, and lead lag compensators. Okay, so that and all we'll see in this unit. Then controllers means there are different types of controllers are there. Proportional controllers and differential controllers, proportional differential, proportional integral differential. Okay, so it's nothing but adding a zero to the transfer function or adding a pole to the transfer function. So with that, what is the effect of adding zero or pole to the transfer function on the system stability point of view, or the transient and the steady state response point of view? That we'll discuss in detail in this unit. Then last unit is a state variable analysis. State variable analysis. So what is the specialty in this unit? To analyze the system, I have already told you there are approaches. One is a transfer function approach. The other approach is called state variable approach. So transfer function approach can be applicable only for the systems which is having the zero initial conditions. That means we are applying by using Laplace transforms. So transfer function means the Laplace transform of output to the Laplace transform of input. So with zero initial conditions. So in this state variable analysis, without zero initial conditions, that means some initial values are there. We can find out the system stability or response by using a state variable approach, analysis approach. Okay, right. So what is the importance of this subject in the GATE exam? So out of 65 questions, how many questions we may expect from this subject? So minimum 4 to 5 questions we'll expect from this subject. So every year, either frequency domain analysis like a border plot, Nyquist, 1 or 2 questions they may come. Then a root locus or time domain analysis. Sometimes RH criteria, they're asking questions. And state variable analysis, 1 question will be there, must. So this is the overview and the importance of the subject in GATE exam. Then what are the reference books for this subject is reference books. You can refer the Nagaratan Gopal, author, is a famous. Then Nagur Kani, one book is there. This is very useful for a practice purpose. So many examples he has worked out, especially the border plot, polar plot, and Nyquist plots. We'll get a lot of experience if you go through the example problems, what he has worked out, various different types of problems. Then we have Benjamin C. Kuo, B.C. Kuo, also a good book. Then Ogot also useful book. We can refer, some of the topics will be covered in this. Right. Now we'll start with first basics of control systems. Okay. So first unit, basics of control systems. First unit, basics of control system. So first of all, we'll see what is the system means. System, what is the definition of system? Definition, that means when a number of elements or components are connected in a sequence to perform a specific function, the group it is formed is called a system. A number of elements or components are connected together or in a sequence to perform a specific function is called system. Okay, just I'll write 2 lines and elements or components connected in a sequence to perform a specific function. The group formed is called a system. Then, what is control system? So, control system means a system consists of a number of components are connected together to for specific function. In this, the output quantity is controlled by varying the input quantity. Then the system is known as control system. The output quantity is controlled by varying the input quantity is called a control system. So there are 2 types of control systems. One is open loop control system and second one is closed loop control system. Right. So what is open loop control system? So open loop control system means the output quantity has no effect upon the input quantity is called open loop control system. For example, if you draw the diagrammatic form, open loop, this is output, this is input. Okay, that means the output has no effect on the input quantity. Then it's called open loop control system. That means there is no feedback from the output to the input, right? Then what is the advantage of this one? So in then first we'll see what is the closed loop. Then we'll compare both closed loop and open loop systems. Closed loop control systems. Here there are different components in closed loop. This controller, a reference input, feedback, positive, negative. So this is negative feedback. Right. Now if you see the open loop and closed loop control systems, the extra is we have the feedback path here. So this is the feedback path. Okay. So why feedback is required? So if you want to have the control on the output from the input side, we have to cross check the system response by connecting a feedback. Okay. For example, if you take the fan regulator. Okay. So what is the speed of the fan? How many rotations per minute or per hour? Okay. So if you want some like 100 revolutions per second, sorry, per minute. Okay. So if you design like that, then suppose the rotations are like less than 100 or greater than 100, that can be cross checked, means error check by connecting feedback. So that's the purpose of regulator. So the fan regulator will rotate the speed of the fan in a particular speed, like a number of revolutions per minute, like. So that is the control. So it's the fan regulator. The fan is a closed loop control system. What is the example for control loop? a closed loop system. Okay. Then what are the other examples for closed loop control systems? Like a temperature control system, then a traffic control system, a numerical control system. These are all the examples for closed loop control systems. Example, a temperature control system and traffic control system. Okay. And air traffic control system. There are different, so many examples are there. Even human being itself is a control system, closed loop control system. Okay. So if we can judge which is correct or wrong. Okay. So suppose you have to reach a particular distance by walk, like 200 meters distance is there. So how much speed you have to go? Okay. Like you are going fast or going less, that you can be judge yourself. So the human being itself is one of the best example for the closed loop control system. Fine. Right. Then what is the feedback here we are using? What are the advantages of open loop system? That we will see now. Advantage of open loop system is the open loop system is nothing but is a simple and economical, and it's easier to construct, and it is more stable than closed loop system. Then what are the disadvantages of open loop systems? That we'll see. We'll write now. So what are the advantages of open loop system? It's simple and economical. Then it is easier to construct, and it is more stable. So these are advantages of open loop system. Then disadvantages, it is inaccurate and unreliable. These are the main drawbacks in the open loop systems. Then advantage of closed loop system, we'll see. What are the main advantages of closed loop system? It's more accurate even in the presence of non-linearities. It's more accurate in the presence of linearities. Then it is less affected by noise. Then disadvantage. What are the disadvantages of closed loop system? It's a complex and costlier. It's complex and costlier. Then the feedback in closed loop system may lead to oscillatory response. That is, the feedback in closed loop control system may lead to oscillatory response. That means there are two types of feedback. So if I use positive feedback, then it will be system may oscillatory. If I use negative feedback, then it's more advantageous. Even the gain may reduce, but the bandwidth will increase. That's the advantages of negative feedback. Okay. Next, the other drawback is the stability is a major problem in closed loop system, and more care is needed to design a stable closed loop system. So here, more care is needed to design this system. So this is the beginning, the overview of basics of control system like open loop and closed loop. Then so here we have to discuss some more basic concepts here. What is linear system and what is time invariant system. So these are the fundamental things if you talk about the LTA systems.